Hello everyone. Today we're going to talk about inverse functions, and by this animation that's playing right now, you'll have an idea of what this is. The inverse functions are functions that are reflected across the y equal x line. Let's give you some examples. Here I have a set of coordinates, and these coordinates belong to a function, and I'm asking you to find the inverse of this function by switching the x and y coordinates of this given function. So it's very simple to find the inverse. All I have to do is take the original coordinates and switch their positions. Here's what that looks like. If in the original set I had a 1, 0 as one of my coordinates, in the inverse of this function, I'll have the point 0, 1. In the original one, I had 3, 2 as another point, and now in the inverse, it'll be 0.23. In the original 4, 0, and then 0, 4, and you get the idea. All we did was we switched the x-coordinate with the y-coordinate to find the inverse of the function, and here's a formal definition of the inverse function. If xy, that means if a point xy, for example, 1, 0, is a point on the graph of a function, then yx, which is 0, 1, is also a point on its inverse. And now we're going to look at this graphically so that you have a better idea of what this means. Here it is. So here are the points, and here on the graph you see the points were plotted, 1, 0, 3, 2, 4, 0, and 5, 5, 5, negative 5. And notice how this line that we just graphed is a function. Okay, and we had found the inverse by switching the coordinates. So I'm going to go ahead and plot these points also on this coordinate plane. And here they are, 0, 1, 2, 3, 0, 4, negative 5, 5. And notice what we have found. We have found a relation that is reflected across the line y equal to x. If I fold my paper across this line, y equal to x, I will have a mapping or a stamped picture of my original function. Notice that the light blue graph is not a function, because if I do vertical line test on this graph like this, and I do it right here, it fails the vertical line test, right? So the inverse of this function is not a function. But anyway, I do want to point this out to you. If I go ahead and look for the domain of the original function and I make a list of all the domain values, I'll have 1, 3, 4, and 5. And if I go ahead and make a list of the range values for this original function, I'll have 0, 2, and negative 5. And remember that domain and range, we usually, let me cross this out, we usually write it in ascending order. So negative 5 would go first, and then the 0, and then the 2. Okay? So if I make a list of the domain and range for the original function, and I go ahead and do the same thing for the inverse, watch what happens. Here the domain is 0, negative 5, 0, 2, if I write it in a ascending order, and the range is 1, 3, 4, 5, 1, 3, 4, 5. Do you notice something here? Notice that the domain of the original function is now the range of the inverse, and that the range of the original function is now the domain of the inverse. So that is expected to happen since we switched, right? We switched the coordinates. So the x values are now the y values, and the y values are now the x values. So that tells me that the domain is now the range, and the range is now the domain. So this is something particular that happens when we look for inverses, that the domain will of the original function will become the range of the inverse, and the range of the original function becomes the domain of the inverse. Okay, so let's look at another example. Again, notice that we already mentioned this, that the inverse of this function is not a function, and we know that by the vertical line test that we did previously. Okay, so this means that not necessarily you will have a function when you do the inverse of a function. So this original graph is a function, but its inverse does not necessarily have to be a function. It can also be not a function, okay? So keep that in mind. Now, how do I know if the inverse of a function is going to be a function without having to sketch the inverse? Well, we do what's called a horizontal line test. You already know how to do the vertical line test, which is proving if the graph is a function or not. But if I want to know if the inverse of this graph will be a function or not, then I do the horizontal line test, and this is what it looks like. You draw horizontal lines across the original function, and if the horizontal line, like in this case here, touches the graph more than once at the same time, then we say that it fails the horizontal line test. Therefore, I know without looking for the inverse of this function that the inverse will not be a function. Okay, so this is a handy tool to know if the inverse will be a function or not. So let's do another example. It says here that given this function, sketch the inverse. And then it asks, is the inverse a function? So I can go ahead right from the get-go and find out if this inverse will be a function or not. All I do is the horizontal line test, and you can see that if we draw horizontal lines across this function, it will fail the horizontal line test. Therefore, I know already that this function's inverse is not a function. Okay, so let's go ahead and find the inverse. Here I have all of these points that I have here labeled -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. I've switched the x and y coordinates. Okay, so here, for example, I have 2, 4, and I've switched it for 4, 2. 1, 1, of course, when you switch, it remains the same, and so does 0, 0. And here I have -1, 1, so I've switched to 1, -1. 4, -2, I've switched to -2, 4. Okay, so these coordinates here are the coordinates of the inverse of this function. So let's plot these points. And here they are. They're being plotted after I switched the coordinates. And you see how this graph is the inverse of the original function. There it is. And notice that it's a reflection of the original graph across the line y = x, okay? And if we do vertical line tests on the inverse, we can tell this is not a function. But we already knew that before we even found the inverse because it had failed the horizontal line test with the original function, okay? How about this function that I'm going to show you now? Is this a function? Yes, this is a function because it passes the vertical line test. Now, will the inverse of this function also be a function? For that, we do the horizontal line test. So if I go across and do the horizontal line test, notice that this test only touches the function once every time. So that tells me that the inverse of this function is also a function. And when this happens, these kinds of functions are very special, okay? They're called one-to-one functions. So remember that whenever a function's inverse is also a function, we call it a one-to-one function. How do we find the inverse of this function? Well, I can just fold this paper across the line y = x, and there you have the inverse of this function. And notice that the inverse, which is blue, it is a function. If I do vertical line test on it, it will be a function. But we already knew that from the original by doing the horizontal line test on it. Okay, sometimes we don't have a graph. Sometimes we just have an equation. So when that kind of thing happens, where we don't have a graph and we can't do vertical line test, horizontal line test, and we can't switch coordinates to find the inverse, then we do the inverse algebraically. And as we do with the graphs, we switch the x and the y. Here's an example. Let's say I give you this function. F of x is x over 6 plus 4, and I ask you find the inverse, okay? So the first thing I do is I write this function in terms of y. Here's what I do. I write, instead of f of x, here's f of x, and instead of f of x, I'm going to write y. So I took this label here and I rewrote it as y. Here it is. That's all I did. Instead of writing f of x, I wrote y. Everything else stayed the same. The next step is replace your y with an x and replace your x with a y, just like what we did with the coordinates. And here's what that looks like. There it is. Instead of a y, I wrote x, and instead of x, I wrote y, okay? Now the next step is you solve for y. So here's what I had done in the previous slide. I had switched x and y. So now I'm going to take y and solve for y. So I'm going to isolate this term here. That means get rid of the 4. So I have to subtract 4 on each side of the equation, right? And this becomes x minus 4 is equal to y over 6. And one more step. How do I isolate y now? To leave y alone, I cross multiply the 6 with x minus 4, and I'm multiplying 6 by both of these terms. So this becomes 6 times x minus 4 equals y. And I'm going to write the variable on the left side. So y is equal to 6 times x minus 4. And there is the inverse of the function that was given. Now the question is this inverse a function, yes or no? And you already know how to determine if an equation is a function or not, right? We know that for every x value, I will have one and only one y value. So this is a function. The inverse of the function is a function. Okay, and if I know it's a function, then I can label it as such. But since this is the inverse, this is how we're going to label it. This is the label we're going to use. This stands for inverse function of x is equal to 6 times x minus 4. Okay, now be careful. If we do the inverse and it is not a function, then we cannot label it with this notation, okay? So again, the inverse function of x is 6 times x minus 4. This means that this is the inverse of the function that was given originally, and that it is also a function. This is not an exponent here. Be careful with that. It's not an exponent. It is just a label and how we label inverse functions, okay?